All right, I'm going to try and just kind of chug my way through the rest of these examples in this video. If you want to, go ahead and pause them, work them, see if you get them right, and then check your answer as I work these along. Now, if you are using the meta calculator and not a handheld TI because you don't have one, you can just graph this on the meta calculator and look for those zeros. Where it's going to be really tricky is if we have to go to the table. And so if we have to go to the table, I'm going to set up a Zoom help session for the meta calculator. Okay, so meta-calculator. Let's do a Zoom session. Okay, let's do it quickly. Let's go ahead and try and do one for tomorrow night. I'll set a time, all right? And so make sure you can check in. Now, I'll go ahead and set an announcement on Canvas for that Zoom session. If you cannot come to this Zoom session, please just get with me. I can do a one-on-one Zoom session. I have no problem with that. You just need to schedule it so that I make sure, give me time to see it, and then make sure I can be available. All right? So let's go ahead and work this first one. X cubed minus 3x minus 2. Now, I'm going to kind of fast forward through the plus or minus p over q list because, especially when this leading coefficient is a 1, all right? Leading coefficient is a 1. I know all those rational zeros are going to be whole numbers, right? So I'm just going to graph this, right? And hope, okay, remember, best case scenario, I'm going to hope to find all 3 zeros. All right, I'm going to hope that graph crosses the x-axis 3 times. So let's go to y equals, and again, if you're on the meta calculator, you just need to type this equation and look at the graph. So x cubed minus 3x minus 2. All right, I'm going to hit enter, and then I'm going to go ahead and graph this and see what it looks like. Oh, touch. Okay, so it touched. It came up and bounced off the x-axis. So it touched at -1 and it crossed at +2. Okay, so the zeros I have here, okay, is because it touches at -1. Remember, if it touches, that means it's a 0 twice. There's a nice alliteration there. Touch twice. Right, so I'm going to list -1 twice, and then it crosses at 2, so that's an odd multiplicity, right? So here are my zeros, -1, -1, and 2. And again, that's because it touched the x-axis at -1 and crossed at 2. So here's all 3 of my zeros. I had a cubic, a third-degree polynomial. I found all 3 zeros from the graph. And so I can write the factors from the zeros. So if -1 is a 0, x plus 1 is the factor. If -1 is a 0, x plus 1 is the factor. And if 2 is a 0, x minus 2 is the factor. And if you want, you can write x plus 1 squared times x minus 2. That is also good. All right. Let's look at the next one. Okay, the next one, again, I'm not going to worry about the p over q list because all the possible p values are the factors of 20 and all the possible q values are 1. So that means I got a bunch of whole number rational zeros as well. You know what? Let me go ahead and practice that. Okay, what are the factors of 20? 20 has a lot. 1, 2 divides it. 3? No. 4 times 5, 2 times 10, 1 times 20. So 20 has 1, 2, 3, 4, 5, 6 factors. And the q values, right, just 1. So how many plus or minus p over q's would we have? We would have 1, 2, 3, 4. These 6 plus or minus, that's 12, right? So we have 12 possible rational zeros, if you will. But how many of them work? Well, let's look at how many. Let's look at the x-intercepts. Okay, So I'm going to go to the calculator again, and I'm going to graph this function. X cubed plus 11x squared plus 8x minus 20. Again, on the meta calculator, it's really easy just to type the function in there, and it graphs it automatically. Okay, so if you're using the meta calculator, this example shouldn't be hard either. Oh, okay. Oh, it looks like there was a 0 way over here. Because the p-values are 20, I might have to widen this screen out. So let me go to the window. I'm going to go negative 20 to 20, okay, and see if that's better. There it is. There it is. There it is. All right. It's only crossing 3. Is that okay? Oh, yes, that's okay. Right? Because we have a third degree polynomial and we have 3 x-intercepts. All right? So it looks like it's crossing at negative 10, negative 2, and 1. Excuse me. Negative 10, negative 2, and 1. Now, just to be on the safe side, I'm going to check that in the table. Okay, and yes, indeed, all right, the table is getting me a 0 remainder. If you wanted to check this on using synthetic, you could divide these out. It's not that hard, okay? Don't grumble. You can just divide each one, and you should get a 0 remainder each time, and then you know you have the right zeros. All right, so we had a third degree polynomial. We found all 3 zeros, so I just need to write those 3 zeros as factors. So if negative 10 is a 0, x plus 10 is the factor. If negative 2 is a 0, x plus 2 is the factor. And if 1 is a 0, x minus 1 is the factor. All right. Notice we are getting x cubed for the leading coefficient. 10 times 2 times negative 1 is negative 20, and that also lines up. All right. Next. Challenge me. Maybe not this one. This one probably just graphs again, because the q value is 1, right? The p value, the factors of 4 are 1, 2, and 4. So if I did plus or minus p over q, I would just get, plus or minus 1, plus or minus 2, plus or minus 4. And so they're all whole numbers. So I'm going to opt to do this the fast way, right, and just graph this polynomial. X to the 4th minus 2x cubed minus 3x squared plus 8x minus 4. Take a peek at the graph. Let me change that window back to 10s, so it'll be a little bit easier to see. Here we go. There we go. Okay, so it's crossing at negative 2, it's touching at 1, and it's crossing at 2. So the zeros we have, okay, are negative 2, 1, and 2, right? Now, remember what it means to touch. Touch means it's 0 twice, right? Touch twice. So because it touches the x-axis at 1, that means 1 works again, right? So I'm going to put another 1 down as a 0, because it's a 0 twice. Touch twice. So here I have 4 zeros. I have a 4th degree polynomial. I can write this in its factored form. Factors. If negative 2 is a 0, x plus 2 is the factor. If 1 is the 0, x minus 1 is the factor. If 2 is a 0, x minus 2 is the factor. If 1 is a 0, x minus 1 is the factor. And because we have 2x minus 1 factors, feel free to write that x minus 1 squared. Okay? Bueno. All right, here we go. Find all the rational zeros of the polynomial and write the polynomial in factored form. Okay, so find all the rational zeros. All right, this has a leading coefficient of 6. This one is going to be really important to write that P over Q list. I am going to start there. Plus or minus P over Q. And this list is going to be quite extensive, right? Because 16 has a few factors, and so does 6, right? So the values of P are the factors of 16. So 1 divides 16, 2 divides 16, 4 divides 16, 8, and 16. The possible Q values come from the leading coefficient. The leading coefficient is 6, so the factors of 6, 1, 2, 3, 6, right? So systematically, we need to put all the P values over all the Q values. So again, I like to put all the P over 1, all the P over 2, all the P over 3, and then all the P over 6, okay? So each row is going to have a different Q value. So I'm going to put all the P values over 1 for row 1. All right, and then for row 2, I'm going to put all these P values over 2. 1 over 2, 2 over 2, 4 over 2, 8 over 2, 16 over 2, right? And then I'm going to put all the P values over 3. 1 over 3, 2 over 3, 4 over 3, 8 over 3, 16 over 3, all right? And then I'm going to put all the P values over 6. 1 over 6, 2 over 6, 4 over 6, 8 over 6, 16 over 6. All right. Now, there are going to be questions on your online homework that are going to ask for the list of your possible rational zeros. Okay, that list has to be a comma-separated list. You're going to have to put 1, comma, negative 1, comma, 2, comma, negative 2. And it is a huge pain in the butt. All right, but you have to be careful not to miss any commas, okay, not to miss any zeros. So you have to be very systematic. Now, on top of that, if there's a duplicate in this list, we need to cross it off. All right, we don't want to list it twice. And so anything that reduces cancels, right? Not the ones over 1. Those ones don't count as reducing, only if the bottom divides the top, okay? So 2 over 2 reduces to 1, and we already have 1 in our list. 4 over 2 reduces, crossing it off. 8 over 2, cross it off. 16 over 2, cross it off, okay? 1/3, 2/3, 4/3, 8/3, 16/3. None of those reduce. So I'm going to leave all those, okay? Now, 2/6 is 1/3, and I already have that, so it's a duplicate. Right? 4 over 6 is the same as 2/3. I already have it, so it's a duplicate. I'm going to cross off the bigger one, okay? 8 over 6 is 4/3, crossing it off. 16 over 6 is the same thing as 8/3. I'm going to cross that off as well, all right? So here is my list of possible rational zeros. Okay, I'm going to ask the famous question, right? How many are there? Right? It is important that you can come up with this list and that you can count up how many possible unique rational zeros there are. 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. Double 12 because of the plus or minus, so we get 24 possible rational zeros. All right. Now, of these 24 possible rational zeros, it would be super nice if we could find 4, right? Because this is a 4th degree polynomial. So our task is to find 4 zeros. So if I can find 4 zeros, I am good to go. So I am going to start with the graph still, right? So let's go ahead and graph this polynomial. Double check. Looks good. And so graph, hopefully it's touching or crossing 4 times. Ooh, there's a fraction. Okay. Of the whole numbers, it looked like -1 and 4. Right? 1, 2, 3, 4. -1 and 4. And then we get these little fraction ones. So that one could possibly be -1/2 because it looks like it's halfway in between there. So I'm going to go to the table and I'm going to plug in -1/2 just to see if I get a 0. And yes, I did. Okay, so I know -1/2 works again. So if you're on that meta calculator, just make the change in table a half, right? And then you can see that you get a y value of 0. So then the other one occurred over here. Let's see if we can get an approximate. 1.2878. 2878. So it's greater than 1, right? So where are fractions greater than 1? 1/3, 2, 4/3 works. 8/3 is greater than 2. So it's probably 4/3, right? So again, I'm going to go to the table. I'm going to type in 4/3. And yes, indeed, okay, 4/3 gave me a 0 remainder. So if you wanted to find and verify that 4/3 was a 0, and your change in table and meta calculator, just change it to 1/3, and then it'll count all your thirds. All right. So I'm going to use 4/3 as my last 0. All right. So I just did that by figuring out where it is and looking at which 0 would fit, and then I double check that with my 0 remainder. Now if you wanted to, okay, you could synthetically divide. Pick a 0 and then do your synthetic division, right? And if you get a 0 remainder, then you know that it's a 0. But it is easier to use the calculator, I agree. So let's go ahead and write these as factors. Right? So if -1 is a 0, x plus 1 is the factor. If 4 is a 0, x minus 4 is the factor. If -1/2 is a 0, x plus 1/2 is the factor. And if 4/3 is a 0, x minus 4/3 is the factor. Now remember, okay, we can't have any fractions. We got to get rid of this fraction, and we've got to get rid of this fraction. All right, no fractions, none. All right. So to get rid of this fraction, I need to take this factor and multiply everything by 2 and distribute the 2. To get rid of this fraction, I need to take this factor and multiply everything by 3. So I'm going to get x plus 1 times x minus 4. If I distribute the 2, I'm going to get 2x plus 1. If I distribute a 3, I'm going to get 3x minus 4. Okay, and here are the factors, right? My 4th degree polynomial had 4 zeros. Here's all 4 factors. The leading coefficient, x times 2x times 3x is 6x to the 4th. The constant, 1 times -4 times 1 times -4 is positive 16. Okay, so everything is lining up there. All right, here we go. All right, this one, here we go. The Q values is a 1, right? And the P values, there's a lot of them. 24 has a real large number of factors. But because the Q value is 1, I think we can just graph this to find the zeros. But notice that this polynomial has 5 zeros, right? So we may have to do the synthetic division thing here. Here we go. What are the factors of 24? 1 divides it, 2 divides it, 3 divides it, 4 divides it, 5, 6, 8, 12, 24. All right. So our possible rational zeros, we're looking at plus or minus 1 to 24, right? So let's go ahead and just graph this and see what happens. Double check. Okay, let's graph. What's going to happen? One, two, three, four. Oh my gosh, they were so nice to us. All right, so it crossed at -2 and -1. It touched at 2 and it crossed at 3. Okay, so if I were to list the zeros out, okay, remember touching means twice. So we're going to get -2, -1. It touches at 2, so I'm going to list that twice, and then it crosses at 3. All right, this doesn't happen. This handout is like super nice to you. All right, you have a 5th degree polynomial. All 5 zeros were found in that list. Okay, it touched or crossed at all whole numbers, and so we really are almost done with factoring this polynomial. Okay, I just need to write the zeros as factors. So we're going to get x plus 2 times x plus 1 times x minus 2 times x minus 2 times x minus 3. Okay, and don't forget, if you wanted to write x minus 2 squared, that is perfectly acceptable. All right, moving on. 6th degree polynomial. So this 6th degree polynomial will have 6 zeros, right? Let's do the, they're going to be either whole numbers over 1 or over 2, right? So halves. So I actually think just graphing this one would be okay as well. All right, 1, 2, 3, 4, 6, 12. Right, so we could put all the p's over 1, all the p's over 2, and come up with that list. But since they're either whole numbers or halves, I think it's pretty easy to spot those. So I'm going to go ahead and graph it. Here we go. Double check. Looks good. All right, graph. See what happens. 1, 2, 3, 4. Okay, so it crossed or touched, right, 3 times, but this 0 counts once, this 0 counts once, and this 0 counts twice. And I do believe that's it. I mean, you can zoom out if you want to, but this is going pretty straight up, okay? So I think we have 4 zeros here, and we need 6, all right? So we have a 0 at -3. That's obvious. All right. I think this 0 is at 1/2, but I'm going to go to the table and double check. Type in 1/2. Make sure oh, you can't even see that. Make sure I get a 0 for the y value, okay? And I do. So it does look like this is 1/2 here. And then it touches, sorry about that, it touches the x-axis at 2. And so because it touches mean twice, and so I'm going to list that 2 twice, right? I have 4 zeros. I need 6, okay? But we're not in a bad situation here, right? If we can find all but 2 zeros, we're sitting pretty, because I can divide these 4 zeros out, break this polynomial down to an x squared function, and then I can use the quadratic formula to find the other 2 zeros. All right? So this one is going to require synthetic division. Yay! You guys know why I like this? Because it's tedious, and I love tedious work. All right. So I am going to divide these. Now, any order, it doesn't matter, but I'm going to go ahead and stick to this order here. Okay, I'm going to do -3, then 1/2, then 2, and then 2 again. All right. Make sure I don't need any placeholders. 6, 5, 4, 3, 2, 1, 0. Okay. So I'm going to divide by -3 and list the coefficients. Okay. The first step, add down, multiply, -3 times 2, add down, multiply -3 and -9, put in the next adjacent spot, add down, multiply -3 times 14, add down. Pardon me for reaching for my calculator here. All right. Multiply -3 times -13. Add down. Multiply -3 times 12. Add down. Multiply -3 times -4. Put in the next adjacent spot and add down. Whew. Okay, you should get 0 remainder. If you don't get 0 remainder, you did it wrong. All right. So now, remember, we're going to piggyback our synthetic division. So I'm going to divide this answer by 1/2, because at this moment, I haven't broken down to an x to the 5th, right? And I want to break it all the way down to an x squared. So I'm going to put 1/2 in the little box here. And I want to divide it into the quotient only, not the remainder. So my synthetic division is going to become 1 column less each time we do this, right? So the first step, remember, is to add down. Okay, 2 and nothing is 2. Now, you might be weary to do fractions, but it is actually going to make these numbers a lot smaller, okay? So 1/2 times 2 is 1. Add down. Half of -8 is -4. Add down. Half of 10 is 5. Add down. Half of -8 is -4. Add down. Half of 8 is 4. Add down. We got another 0 remainder. Okay, so now I have 2, negative 8, 10, negative 8, 8. Right? So here's the quotient, the remainder. We've now broken this down to an x to the 4th polynomial. Okay, let's keep going. Let's divide out both 2's here. So I'm going to divide into the quotient only. I'm going to stop shy and not divide into that remainder. The first step, add down. 2 times 2 is 4. Add down. 2 times negative 4 is negative 8. Add down. 2 times 2 is 4. Add down. 2 times negative 4 is negative 8. Add down. Okay, another 0 remainder. We're still going good. Right? So now, if this is x to the 4th, this is my x cubed. I have it broken down to a cubic. One more time, and I will have the quadratic that I was looking for. Okay? So first step, bring the 2 all the way down here. 2 times 2 is 4. Add down. 2 times 0 is 0. Add down. 2 times 2 is 4. Add down. Here's my 0 remainder again. Okay, so we started off with x to the 6th, x to the 5th, x to the 4th, x cubed. This is the x squared. This is the x. This is the constant. All right, so right now we have our factors. And this one does something interesting I want to make sure you see. Okay, negative 3 divided it, so x plus 3 is the factor. 1/2 divided it, so x minus 1/2 is the factor. Don't change this yet. 2 divided it, so x minus 2 is the factor. 2 divided it again, x minus 2 is a factor. And this quotient here is our other factor. Okay, so the quotient was 2x squared plus 2. Right? Now these are the factors. Okay, if they don't factor any further. But notice how you can take out a 2 out of this factor. Right? So if I take a 2 out of this factor, that is the 2 that we were multiplying times this fraction. The reason why it didn't happen before is because we didn't do our synthetic division. Okay? But what we need to do is we need to take a 2 out of here and multiply it here. All right? So if I take a 2 out of this factor, I'm going to have x squared plus 1. Right? And now this factor is factored completely. And I'm going to take that 2 and I'm going to distribute it here. Right? So I'm going to get x plus 3. I'm going to get 2x minus 1. And then I'm going to get the x minus 2 times the x minus 2 times the x squared plus 1. Here it is factored completely because none of my factors factor any further. Now, where are the other zeros? Okay, so the other zeros come from our quotient. So if I take the 2x squared plus 2 and set it equal to 0 and solve, that's where the other 2 zeros come from. So this one, we don't need to do the quadratic formula because we don't have a middle term. Right? You can. Right? There's nothing wrong with that. But I am going to just move the 2 over. Subtract 2 from both sides. Divide by 2. And now what happens when we take the square root? Okay? We get x equals plus or minus I. Okay? The other 2 zeros were imaginary, which is why they didn't show up on the graph. Right? So it is true that this function has 6 zeros. All right? Negative 3, 1/2, 2, 2i, and negative I. Okay? These are both real and complex zeros. But I want you to be aware, if the question just asks for the real zeros, they do not want you to put the i's in there. Okay? So if it's asking for the real zeros only, the real zeros only are negative 3, 1/2, 2, and 2. Okay? You don't want to include the i's. All right? Now we did have to do all this work just in case those other zeros were irrational. Right? we do want to do this. You always want to make sure you have all 6 zeros. Okay. All right. I have 2 more. 35 minutes. I think I'm going to stop this video and start another one. Okay.